Derivatives of exponential and logarithm functions. First, exponential derivatives. So we have number one, function of x is equal to a exponent x, and the derivative or function of x prime is equal to ln of a multiplied by a exponent x. Number two, function of x is equal to e exponent x, and the derivative function of x prime is equal to e exponent x. Number 3, function of x is equal to a exponent of g of x, and the derivative function of x prime is equal to ln of a multiplied by a exponent g of x, and the derivative of g of x prime. Number 4, function of x is equal to e exponent of g of x, and the derivative function of x prime is equal to e exponent g of x, and the derivative of g of x prime. Logarithm derivatives. Number 1, function of x is equal to log base of a of x, and the derivative function of x prime is equal to 1 all over ln of a multiplied by x. Number 2, function of x is equal to ln of x, and the derivative function of x prime is equal to 1 over x. Number 3, function of x is equal to log of base a of g of x, and the derivative function of x prime is equal to g of x prime all over ln of a multiplied by g of x. Number 4, function of x is equal to ln of g of x, and the derivative function of x prime is equal to derivative of g of x prime all over g of x. Example: differentiate each of the following functions. Number 1, function of x is equal to 3 times e exponent x plus 10 times x exponent 3 times ln of x, and we differentiate function of x prime is equal to 3 of e exponent x, or 3. What is the differential of e of x? Based on exponential derivative, function of x is equal to e of x, and the derivative is equal to e of x. So 3 times e exponent x is the derivative, plus copy the constant 10, and x cubed times ln of x, we will be using product rule. And the formula for product rule: u times derivative of v over dx plus v derivative of u over dx. And x cubed, what is the derivative of ln of x, which is based on logarithm derivative? Ln of x, or the function of x, is equal to ln of x, and the derivative is 1 over x. So this is 1 over x plus v, and v is ln of x, so ln of x, and then what is the derivative of x cubed? Based on power rule, it is 3x 3 minus 1, or 2, and close parentheses. And after that, we simplify. Copy 3 times e of x plus 10 multiplied by x cubed times 1 all over x. X cubed all over, or x cubed over x, cancel out x. So x and 2. And this is 10 x squared plus 10 times the constant 3 or 30 and x squared and multiplied by ln of x. And this is the derivative of problem number 1. Example number 2. Y is equals to 5 times e of x all over 3 times e of x plus 1. Using the quotient rule, and the formula for quotient rule, we have uv is equals to v derivative of u over dx minus u derivative of dv over dx, and divide by v squared. And what is u? U, based on the given, it is e of x, and derivative of u over dx, and e of x based on exponential derivative, the derivative is equal to e of x, so it is the same value. V, and v 3 e of x plus 1. Derivative of v over dx, which is 3, and derivative of e of x is also e of x plus 1. The derivative of 1 is 0. So now we derive. So y prime, we copy the constant 5, and using the quotient rule, we have e of x all over 3 times e of x plus 1, and using the quotient rule, v is equal to 3 times e of x plus 1, open close parenthesis, and we multiply by the derivative of u, which is e of x, minus u, which is e of x, and what is the derivative of v? It is 3 times e of x, so 3 times e of x, close parenthesis, and divide by v, or v squared, which is 3 times e of x plus 1, open close parenthesis, squared, and we close the parenthesis. And we simplify. 5 times 3 times e of x times e of x, this is 15, and e of x times e of x, it is equivalent to, we add the exponent, so e of x times e of x, we add the exponent, or 2x, so 15e exponent 2x, and then plus 5 times 1 times e of x, or 5ex, minus sign 5 times 3, also 15, and multiplied by e of x times e of x, or e, we add up the exponent x, or 2x, and we divide with the denominator, which is 3 e of x plus 1 squared, and we have the same terms, 15e exponent 2x minus 15e exponent 2x, so cancel out, and the value is equal to 5 e of x divided by, which is 3 e of x plus 1, open close parenthesis, square, and this is the derivative. Example number 3. G of t is equal to 4 times log base of 3 of t minus ln of t. So we have two terms. So derivative of g of t, or g t prime, is equal to, copy the constant 4. And what is the derivative of log base of 3t? Based on the logarithm derivatives, log of base a of x and the derivative is equal to 1 over ln of a times x. So what is a? And it is equivalent to 3. And x, based on the first term, it is t. So we multiply by 1 all over ln of 3, and we multiplied by x, which is times 3, or t, 1 over t ln of 3. And the second term, derivative of ln of t, and based on the logarithm derivatives, ln of x and the derivative is equal to 1 over x, or in this case it is 1 over t. Simplify. 4 times 1, or 4, and we divide by t ln of 3 minus 1 over t. And this is the derivative. Number 4. R of w, or the function rw, is equal to 3 exponent w times log w. Using the product rule, the formula uv is equal to u times derivative of v, or dv over dx, plus v derivative of u over dx. And in this case, u, it is equal to 3 exponent w. So derivative of u over dx, 3 exponent w, based in exponential derivative, function of x is equals to a of x, where a is the constant 3 and x is w, or the derivative is equals to ln of a multiplied by a of x. Simply we copy 3w and we multiplied by ln of a, which is 3. And next, v is equal to log w, and derivative of v over dx, log w, based on the logarithm derivatives, we have log of a, log base of a of x, and the derivative is 1 over ln of a times x. And in this case, log, we have a base with 10 of w, so therefore this is 10. Derivative of v over dx is equivalent to 1 all over ln, and a is equivalent to 10, and multiplied by x, which is w. And we go to derivative of rw prime is equal to product rule, u, which is 3 exponent w, and the derivative of dv over dx is 1 all over w, then ln of 10, plus v, and v is log of w, and we multiplied by the du over dx, which is 3 exponent w times ln of 3. So this is 3 w ln of 3. and simplify. So this is 3 exponent w all over w of ln of 10 plus 3w ln of 3 and log w. And this is the derivative. Example number 5. Function of h of y is equal to y all over 1 minus e of y. So we will be using quotient rule. And the quotient rule, u over v, which is derivative of v derivative of du over dx minus u derivative of v dv over dx and divide by v squared. And example number 5, u is equal to y, the numerator, so y, and derivative of that is du over dx, and it is equal to 1. V, which is denominator, 1 minus e of y, 1 minus e of y, and derivative of dv over dx, it is equivalent to 1, is 0, minus derivative of e exponent y based on the exponential derivatives, it is e of x or e of y. And then we substitute based on the quotient rule. So h y prime is equal to v, which is 1 minus e sub y, and multiplied by du over dx, which is 1, minus u, which is y, and multiplied by du over dx or dv over dx, which is negative e of y. So negative e of y, and divide by v squared, which is 1 minus e of y squared. And we simplify. 1 times 1 is 1 minus negative ey, e times our exponent y times 1, or negative e exponent y, minus it is plus y e exponent y, and we divide by 1 minus e sub y squared, and this is the derivative. Example number 6. Function of t is equal to 1 plus 5t all over ln of t. We have a numerator and denominator, and we'll be using quotient rule, and this is the formula. And what is u? U is the numerator, which is 1 plus 5t, and derivative of u over dx is equals to derivative of 1 is 0, derivative of 5t is 5. V, and the denominator is ln of t, and derivative of dv over dx, ln of t based on logarithm derivatives, it is equivalent to 1 over x or 1 over t. And we substitute based on the quotient rules. Function of t prime is equal to v, which is ln of t, and multiplied by the derivative of u, which is 5, minus u, or 1 plus 5t, and derivative of dv over dx, it is 1 over t, and divide ln of t squared, and simplify. Ln of t times 5, it is 5 ln of t, minus 1 times 1 over t, it is negative 1 over t, and minus times positive 5t times 1 over t, it is equivalent to negative 5 and divide by the denominator of ln of t squared. And this is the derivative. Example number 7. The function of h of x is equal to 3 of x all over 3 of x plus 2. So we have a numerator and denominator. So we'll be using the quotient rule with the same formula. And we identify what is u. The denominator is 3 of x. And derivative of du over dx, which is equivalent to a of x. And derivative is ln of a times a of x. A is 3 and our exponent is x. So this is 3 of x times ln of a, which is 3. And next, v. The denominator is 3 of x plus 2. And derivative of dv over dx, derivative of 3 of x is also ln of a times a of x, or 3 of x times ln of 3, and derivative of 2 is 0. And then we substitute based on the formula for quotient rule. And this is h of x prime is equal to v, which is 3 of x plus 2, open close parenthesis, and derivative of du over dx, which is 3 of x ln of 3 minus sign, and u, which is 3 of x, and derivative of dv over dx, which is 3 of x ln of 3, and we divide 3 of x plus 2, open close parenthesis, squared. 3 of x times 3 of x times ln of x, twice of 3 of x and ln 3, plus twice of 3 of x times ln of 3, or this is 2 times 3 of x ln of x, and then minus 3 of x times 3 of x times ln of 3, or this is twice of 3x ln of x, or ln of 3, and we divide by 3 of x plus 2 squared. And based on the numerator, we have two similar terms. So 2 times 3 of x times ln of 3 minus 2 times 3 of x ln of 3, and this will be cancelled out. The remaining value, it is equivalent to 2 times 3 of x times ln of 3, and we divide by 3 of x plus 2, open close parenthesis, square, and this is the derivative. Example number 8. Function of x is equal to ln of x squared times sine x all over 2x plus 1. First, we need to simplify based on the properties of logarithm. Ln of x squared, or this is 2 ln of x, plus ln of sine x we have ln of 1 over 2x plus 1, or this will be negative of ln of 2x plus 1. Once we simplify, we can now derive. So function of x prime, and this is equivalent to 2. What is ln of x? Ln of x is equal to 1 over x, or 1 over x, plus what is the derivative of ln of sine x. It is also 1 over x. However, we have to differentiate the value for sine x, which is derivative of sine x is cosine x. And this will be 1 over sine x, which is the derivative of ln of sine x, and derivative of sine x, which is cosine x, minus derivative of ln of 2x plus 1, the same formula, 1 over x, or in this case our value x is 2x plus 1, and we derive the value for 2x plus 1, and derivative of that is 2. So this is 1 all over 2x plus 1, and derivative of 2x plus 1 is equivalent to 2. So this is 2 over x plus cosine of x all over sine x minus 2, and we divide by 2x plus 1. 2 over x, and based on identities, cosine of x over sine x is equal to cotangent of x, minus 2 all over 2x plus 1, and this is the derivative. Example number 9. Find the tangent line to function of x, which is equal to ln of x multiplied by log base of 2 of x at x is equal to 2. So we copy first. Function of x is equal to ln of x times log base of 2x. Use product rule, and function of x is equal to, so u is equal to ln of x, and derivative of du over dx is equal to 1 over x, and v, which is log base of 2 times of x, and derivative of dv over dx for log, which is 2 function of x is equal to log of base of a times of x, or the function of x prime is equal to 1 over ln of a times x, or this will be 1 all over x ln of 2 using product rule. So we have u, which is ln of x, and multiplied by the derivative of dv over dx, which is 1 over x ln of 2, and then plus v, which is log of 2 of x, base of 2 of x, and the derivative of d over dx, which is 1 over x. At x is equal to 2, first function of x is equal to ln of 2 log base of 2 of 2. The value of this for log base of 2 of 2, it is equivalent to 1, and the value for that is ln 2, and this is for function of x. Next, we find the value for the derivative of x. So function of x prime, and x is equal to 2, so ln of 2 all over x is 2 ln of 2 plus log base of 2 all over x, or 2. We cancel out ln of 2 over ln of 2, and this will be cancel out, and log of base 2 of 2, and this is equivalent to 1. This is 1 over 2 plus 1 over 2, and f prime of x, the value is equal to 1. So this is f prime of x. Using the equation of the tangent line, so tangent line, we have the formula for that, which is y is equals to function of x plus function of x prime, and we multiplied by x minus x1. So we have a function of x equivalent to ln of 2, function of x prime, which is equivalent to 1, and x1, which is equivalent to 2. And y is equals to function of x, which is ln of 2, plus function of x prime, which is equal to 1, and multiplied by x minus the function x1, which is equal to 2. Y is equals to ln of 2 plus 1 times x is x, 1 times negative 2, it is negative 2. And we arrange x, y, transfer to right side, which is negative 1, negative y, and minus 2 plus ln of 2, and it is equivalent to 0. And this is the equation of the tangent line. And that's example number 9. Example number 10. Determine if v of t is equal to t over e of t, which is increasing or decreasing at the following points. So we have a, which is t is equal to negative 4, and b, or t, is equal to 0. First, we copy v of t is equal to t over e of t. And using the same quotient rule, u is equal to t, and du over dx is equivalent to 1. And v, the denominator, which is e of t, derivative of dv over dx, is also e of t. And then substitute based on the formula for quotient rule. So v of t prime is equal to e of t multiplied by du over dx, which is 1, minus u, which is t, and derivative of dv over dx, which is e of t, and divide by e of t squared, so et squared. And we simplify. We have e of t minus t e of t all over e of t squared. And then we extract similar term, which is e of t, and this is 1 minus t, and divide with e of t squared, and we cancel out e of t and e of t, which means exponent 1, and the remaining value is equal to 1 minus t all over e of t. And this is the derivative for v of t prime. Once we have the derivative, we substitute the value for t, which is for a, or t is equals to negative 4, and another value for t, which is equal to 0. And we need to determine if it is increasing or decreasing. T, which is equal to negative 4, we have v of t prime is equal to 1 minus 4 all over e of negative 4. And this will be 1 plus 4 and divided by e negative 4, or 5 over e negative 4. And the value for that, it is equivalent to 5 over e of negative 4. Based on our calculator, the value is 272.991, which is greater than 0, and the value is increasing. at t, which is negative 4. What about at t, which is equal to 0? So same thing, v of t prime, and equate to 0 the value for t. So 1 minus t, which is 0, all over e exponent 0. And the value for e exponent 0 is equivalent to 1. And we have the value for that, which is equivalent to 1 over 1, or 1, which is greater than 0. Therefore, at t is equal to 0, the value is also increasing. At t is equal to 0. So this is the solution.